So let's say we want to conduct a multi-group analysis of a path model. We have a fairly simple model here. 3 independent variables connected to 2 dependent variables, except the line from customer rejection to job satisfaction. Really, that's just an oversight. Whoops, but no worries, we'll learn the same things. So, I've already typed out the syntax for you. I'll just describe a couple of the nuances here. Notice I've added this grouping is job cat, and then I've defined what the groups are. In our case, we have 0s and 1s in the job category column. The 0s represent customer service representatives, and the 1s represent bill collectors. So we have to define those if we're going to do a multi-group analysis. I've also requested standardized estimates and confidence intervals. I've defined the model here. Something new is that I've labeled each of these paths, B1, B2, B3, B4. It's important that you label these on separate rows. Labeling them on the same row will throw you an error, or including only a single label on a multi-independent variable row will actually change your output. So make sure you define these on separate rows. What we're doing by defining these labels is constraining these two models, well, the same model across these two groups, to be equal on each of these paths. By naming empowerment to job satisfaction B1, we're saying force the effect to be identical across customer service and bill collectors. So this is the constrained model. What we'll do is we'll save this, run it, and then we're going to take note of the model fit information, specifically the chi-square in degrees of freedom. We'll just open up Excel and conduct a chi-square difference test, specifically the chi-square right tail. So let me put some placeholders in here. We'll have our constrained, unconstrained, and the difference for chi-square, I'll just say x2, and df, degrees of freedom. And then the formula is going to be something like chi.dist.rt, and we're going to insert those two things, the difference in chi-square and degrees of freedom. And it'll spit out a p-value for the right-tailed probability. So, for this constrained model, we have chi-square value of 64.195 and a degrees of freedom of 8. 64.195 and 8. Next, we need to go do an unconstrained model. To do that, all you have to do is remove those label constraints. So, I'll get rid of B1, B2, B3, and B4. And I do recommend saving this as a different file just so you can keep things straight, because this is no longer the constrained, this is the unconstrained. And it's the full model. So let's do File, Save As, call this MGA Unconstrained. I probably have one already named that, but that's alright. Yes, I'll replace it. And we'll run it again. And this model does not constrain those paths to be equal across groups. So this is fully unconstrained. We'll go to the model fit information. Chi-square is 62,866 and degrees of freedom is 4. 62,866 and 4. We can easily calculate the differences, equals this minus this. And this is obviously 4, but if you want to be consistent, equals this minus this. And our calculation is now equals chi dist rt. Looks like I missed a couple letters in that formula earlier. It is chi square, sq, dot dist dot rt. And the difference in chi square is this one. And the difference in degrees of freedom is this one. And hit enter, and here's the p-value for the difference. So this means that there is no difference between these two models. When they're forced to be equal and when they're let free, it is essentially equivalent. So in this case, job role, customer service versus bill collector, does not seem to make a difference. Now let's say we wanted to test a single path to see if that path was different. We could do that. Now what we might do first is, well, probably we'd have some theory about it, but if we were just looking around here, we might just go look at the model results first to see if there was some path that had a major difference. So here are the results for the CS group, and below this you'll see the results for the BC group, and we may look to see if we can find any big differences in the estimate column when comparing against the BC group here. So we see 613, 672, not a big difference. 192, 113. That's a bit of a difference. 109, 108, 123, 0.074, but not significant for this group or for the other groups, so probably not important. 0.071, but not significant. Let's look at the significant effects here. And really it's just these ones up top. So let's go check the path difference for this top one. Empowerment to job satisfaction. And then we might try feedback to job satisfaction. The way we do that is we go ahead and reconstrain all of these except the ones we want to test, one at a time. We set empowerment on job satisfaction and then feedback on job satisfaction. Let's start with empowerment. So I'll just name these other ones. Just call this B2, B3, and B4. And save this as a different file for now, just so we don't get confused. This is just a single path being constrained. See, MGA, unconstrained path, save. Yes, I'm going to overwrite this one, and I'm going to rename it up here, unconstrained path. Okay, so this will check to see if the model is different based on releasing the effect from empowerment to job satisfaction. We save, we run, we check out the model fit information, get the chi-square and degrees of freedom that we want to compare to the fully constrained model. So that's 64.043 and 7. Go back to our Excel, and we'll just replace this unconstrained number here. 64.037 and 7, was it? 64.043 and 7, sorry. 64.043 and 7. And the answer is, nah, there's no difference. Let's try this one more time, but for feedback, just go down here and get rid of this one. Oops. And give this one a label. Save that, run it again, jump down to the model results, the model fit results, and get those chi-square and degrees of freedom, 63.013 and 7, 63.013 and 7, and while it's approaching significance a little more closely, it is still pretty far away. There is no difference on that path, so we would say that job role does not moderate that effect.